All right, so here we got one last one, and this is on construction labor. So it says the personnel manager for a construction company keeps track of the total number of labor hours spent on a construction job each week during construction. Some of the weeks and the corresponding labor hours are given in the table to the right there. What we're supposed to do is use that data, find a logistic model for the data in the accompanying table, then write the derivative equation for it. And then we're supposed to, on the interval from week 1 through week 19, when is the cumulative number of labor hours increasing most rapidly? How many labor hours are needed in that week? If the company had a second job requiring the same amount of time and the same number of labor hours, a good manager will schedule the second job to begin when the cumulative number of labor hours per week for the first job begins to increase less rapidly. So basically, after that inflection point. So it's probably going to look something like this. And so, we have our point of inflection. So sometime past that, then they will start doing, getting ready for that second job. All right. So what we need to do is we need to plug that data into our calculator. And because it takes a long time to do that, that's already there. And so now it says to create a logistic model. So we'll do that. We need to put that into vars1. And so this is going to be our values as far as our equation goes. So it's going to be 10,111.10245 over 1 plus 1153.22161 e to that there. Okay. Now, if we keep all those decimal places, that will be the most accurate numbers. If we round it, then along the way, we're going to lose some accuracy and we're going to get different values, especially if we're trying to match any book values, they're not going to match. But, what we're going to do is we're just going to round and we're not going to worry about that too much. So let's go and start working on our formulas here. So if we say that f of x was equal to, and we had the number 10111.102, and then that was over, and we had 1 plus 1153.222, and then e to the minus 0.728x, and that was ours. Okay. So now we need to find f prime of x. So let's not even put that because we're just going to start taking the derivative using what we need to do. So here we're going to have our inside through outside function. So we'll have g of x equals the negative 0.728x. F of g equals, and that's going to be 1 plus 1153.222 e to the g. And let's call then that, I don't know, h of f, and that's going to be 10111.102, and then it's going to be f to the negative 1. So now finding our derivatives, we get a negative 0.728, 1153.222 e to the g, and a negative 1011, another 1.102 f to the negative 2. All right, so that gives us then our first derivative without simplification. So that's going to give us negative 0.728 times 1153.222 e to the negative 0.728x, and then times negative 11011. And now do I have enough ones and right number ones? 10. Okay. Why do I have 1031s? Then I don't know what I did there. So let's start that number over. 10111.102 and then times, and we have 1 plus 1153.222 e to the negative 0.728x to the negative 2. Okay, now we can multiply that, and that together, and we can simplify. And so f prime of x is equal to, and if we take all that, we get 0.728 times 1153.222. And again, this is where rounding is going to get us a slightly different answer, but we'll be happy with it because then we don't have to carry out all those decimal places. All right, so that gives us 8488,731.357 e to the negative 0.728x. And then it's all still times our 1 plus 1153.222 e to the negative 0.728x to the negative 2. Okay. Now, once again, we're going to have to take and do parts, that piece times that piece. And so we'll have our h of x is equal to the first part, 84,88,731.357 e to minus 0.728x. And our g of x, we're going to say that's equal to the other part, and that's going to be 1 plus 1153.222 e to minus 0.728x to the negative 2. Oops, HG. Oh, well, we'll rewrite that one. I usually do GH, but I guess I wrote, well, maybe we can do it GH still. GH, and then so this is G prime of X. So we'll take that number, and so 84,88,731.357 times, now when we take the ln of that, we get a negative 0.728, and then it's times e to negative 0.728x. Now, simplifying that, we get times negative 0.728. That gives us negative 617,996.428 e to the negative 0.728x. Okay. All right, so now what we have to do is we have to do our inside-outside functions here. Maybe we can have enough room up here so we can kind of get that all on one page. And so if we do our g of x is equal to negative 0.728x, our f of g is equal to 1 plus 1153.222 e to the g, and our I don't know, h of f is equal to now we have f to the negative 2. So now g prime of x, f prime of g, and h prime of f. Well, that's a negative 0.728. This is 1153.222 e to the g, and this is a minus 2 f to the negative 3. And so that gives us h prime of x equals, now we just multiply all those together, and then times negative 2. And then because we are out of room, I'm going to put the other piece on the bottom already. So that's 1 plus 1153.222 e to minus 0.728x cubed. Okay. And so once we multiply those pieces out, we can put that down here for our h prime of x. All right, so if we do that, we have 0.7, oops, negative 0.728 times 1153.222 times negative 2. So that gives us down here 1679.091232, and that's e to the minus 0.728x all over 1 plus 1153.222 e to the negative 0.728x to the third. Okay. Now we're going to use g to the x times h to the x plus g to the x times h prime of x. Okay. And that will give us, hopefully we have more pages. Now that's our f double prime, our second derivative of x. And if we multiply that, we get negative 61797 e to minus 0.728x. And that was over the thing to the squared, 1 plus 1153.222 e to minus 0.728x squared plus, And now let's go ahead and do this all in one step. We'll take our 1679 times 84, 88, 731.357, because we're going to take this one times this one, and that gives us, all right, that gives us a huge number. And then we have this times this, and remember, when you multiply those together, you add our value. So it's going to be 6 and 5 and then 14. Okay, so that gives us, that huge number was 1425335 439, and we had times 10 to the 10, so 1 2 3 4 5 6 7 8 9 10, and then it was e to the negative 1.456x all over, and then we had 1 plus 1153.222 e to the minus 0.728x cubed. All right, so we get that. Now I'm going to pause. I'm going to plug this into our calculator, and we're going to get out our x values. So just a second. All right, so I've got it all typed back in, and so here is the long equation, and now we just have to graph. And I don't know, let's 7. That looks good. Do 7. I don't know. There we go. 9.684. Okay, that seems like a logical number. And if we would have graphed our original function, we could see where we think the inflection point is. But we'll go with that. And so we get x equals 9.684. And so what we need to do is we need to find what f of 9.684 equals and f prime of 9.684. And if we plug those in, let me get back and I'll type that real quick. All right, so instead of typing, what we're going to do, I made sure we had everything in our calculator, and we're going to do our second trace, and we're going to do a value, and we add the 6 or 9 point, I should say, 9.684, and we get 53.798. Okay, so let's write that down. 53.798. And for our other one, we could just arrow down and we'll find our prime. And that's going to be 1840.134. All right, so this was 53.798, and that was 1840.134. And so that's going to be hours. And this is going to be hours per week. And again, remember, this is what it is. This is the rate it's changing at this point in time. Okay. And so it's like 9.7 weeks later. So what we could say is the most rapid rate of change is at 9.7 weeks. So after maybe 10 weeks, the manager, or what did they call him? Yeah, manager could start the next project. Because that was the whole key. They wanted to know for D. So this one, we knew when is the cumulative hours for labor increasing most rapidly. Well, that was at 9.7 weeks. It was accumulating most rapidly. And so then this one says, well, leading into that, what would be a good time to do the next job? And remember, it is when the first job begins to increase less rapidly. Well, it's going to increase less rapidly after this point in time. So if we round up to the next week, we would do after 10 weeks, they could start the next project. Okay. So hopefully that'll help you. Again, the logistic ones are going to take more time to do everything, but it's kind of satisfying when you get done and get to the end and you get your answers and you understand what those answers actually mean.